Hello everybody, this is Professor Mark and I teach chemistry, and I think I have a really good way and a fun way to calculate the oxidation number for a transition element, okay, in a compound. For example, if you have vanadium pentoxide. Now think of the vanadium pentoxide, the compound, the whole compound as a hospital. Hospital. Where the one on the right side, they always want money. Okay, they need money, so you have to donate the money for them. And how do you know how much they want? In fact, you look in the periodic table, where the first group always donates $1. Should I say $1? And the second donates $2. Third donates three. Leave that alone now. And the fifth, they always wanted $3. Sixth, they wanted $2. Seventh, they want $1. They want $1. Okay, for example, so oxygen wants $2, but we have five oxygen, and that means that all of them wants $10. But who will give them the $10? Who will give them the $10? The one on the left side. That's vanadium. So vanadium will give all the oxygen atoms the $10. But I am concerned about how much each vanadium will give. We have two vanadium atoms. We have two vanadium atoms, and each of them, and I'm sorry, all of them will give the oxygen atoms $10. That means that if we divide the $10 um, evenly on them, each one will give $5. And that's the oxidation number that we're calculating. Now, let me write another example like this. That's potassium dichromate. Now, you have to deal with this as a hospital, as we discussed. Okay, that's the transition element that you want to calculate its oxidation number. But you know the oxygen. Now you have to like split these. The oxygen wants $2, and you have 7 oxygen atoms. That means that all of them will get $14. I'm gonna leave that aside for now. $14. So all of them will get or wants to want all of them want $14. Now these people here will give the oxygen atoms of the $14, but how much each of them will be willing to give? Well, I don't know about the chromium, but I know about the potassium, because the potassium has a fixed oxidation number, which is +1. So each potassium will give $1, and since we have two of them, then they will give $2. But the oxygen atoms need $14. All of the potassium atoms will give $2. How many left? Or how we deficit we are? How many left to get to the 14? $12, correct? But we have two chromium atoms, and I'm concerned about each individual chromium atom. Yes, if we divide them evenly, each chromium will give $6, which is the oxidation number. So whenever you have a situation like this, you can think of the oxidation number as a hospital, and then go directly to solve this kind of problem. Anyways, thanks for watching. Have a good day.